over 10,000 carriers. I'm not aware of them.
Well, in the wholesale space, we can break down the 10,000 carriers generally into three categories. So we have three tiers. So the tier 1 carriers, they number about 1,200. And they're all the household names that you're familiar with here in North America. That'd be companies like AT&T, Verizon, Bell Canada, TELUS, etc. And then we have the tier 2 carriers, who are also large carriers. They number about 400, but they're generally non-facilities-based carriers. And then we have the small dealer broker types that make up the remaining 8,000 or so.
So what's TessPay's role in this whole supply chain?
TessPay is a blockchain-based payment settlement system, making extensive use of smart contracts within the TessPay IBM blockchain to provide payment assurance, liquidity, speeding settlement, and generally making the whole process more efficient and less costly. Automated daily settlements guarantee that carriers get paid on time every time.
So what are the benefits of using TessPay? Every stakeholder wants to know, how is it good for me?
Well, for tier 1 carriers, they get fraud mitigation, settlement efficiency, and a more stable source of supply, whereas for tier 2 and 3 carriers, they get payment assurance and liquidity.
So how do lenders actually benefit with TessPay?
Well, lenders also get several benefits as well. They have a much more efficient credit review processes, and I'll talk about a little bit later. The current process is very time-consuming and expensive. They also get a secure platform to ensure that the services have been rendered for the invoices that they're purchasing. And lastly, they get access to TessPay's bespoke insurance plan to give them lower cost insurance cover.
I think at this point, I'd like to know much more about actually how do the calls flow?
Okay, so let's take an example of, let's say an AT&T subscriber calling from San Francisco to a caller in London, England. So the call would first go to AT&T's cell tower or landline network, depending on how the call was actually placed. Then the call would arrive at AT&T's core network. At that point, the network would make a routing decision and try and find a termination partner for the UK. So let's call that supplier A in this example. So supplier A, when the call is received to its network, would make a similar routing decision, pass it on to supplier B, and so on down the line until it reaches the final termination point in the UK. Now, one thing to note here is that while I'm presenting or illustrating this example in a linear fashion, in reality this looks much more like a matrix, because each carrier has multiple carrier options for each destination.
So why so many carriers for a single call?
Well, that's a natural question. If you've never spent time in wholesale telecom, like, why so many? But that's because wholesale telecom is actually a combination of telecom and finance. So the tier 1 carriers, who originate most of the calls naturally because they're the ones that have all the retail customers, due to their size and buying power, they typically demand 30-30 payment terms. So that means an invoice once a month, and then you get 30 days to pay. So supplier A is essentially granting 60 days of financing to that tier 1 carrier. So then supplier B may, for example, in turn provide 15-15 financing terms to supplier A, thus reducing A's financial exposure from 60 days to 30 days, and similarly C may offer 7-7 to B, the terms getting shorter and shorter as you move down the line, reducing B's requirement from 30 days to 16 days, and so on down the line to where maybe at the end it's prepay.
So the financial component's just as important as the actual call flow traffic.
Yeah. So what you'll see here is that the financial exposure is actually being shared in kind of an uncoordinated way throughout the chain. And this is actually sourced from a combination of accounts receivable, factoring, bank credit line, or shareholders' equity.
So when I make a call, it's a combination of the telephone, connectivity of infrastructure, and then the financial processes. Isn't there a lot of fraud in this?
Yes, unfortunately there is some fraud in the industry, as I mentioned earlier, that I experienced firsthand.
Why don't you give me an example of some of the types of fraud?
Well, first of all, there's two different kinds of fraud. There's financial fraud and there's telecom fraud. So let's talk about financial fraud first. So credit fraud, for example, would be a customer with malice obtaining credit from a supplier with the intention of ramping that credit up over a period of time. And once they feel it's reached the maximum level, they'll just disappear.
That's interesting. So does social engineering work into fraud as well?
Yes, so the fraudsters also use social engineering techniques. So what happens in this circumstance is the fraudster, who's not actually a party to the contract, masquerades as one of the other parties. So for example, they'll send an email to a customer or supplier asking for banking coordinates to be changed, or for a fraudulent IP to be added to an authorized access list. And typically they'll do this by, let's say, changing one letter in the domain name of a customer or supplier, using the exact same footer, name, etc. So the party that's receiving the email doesn't know that it's not their customer or their supplier. They think they're legitimately taking a request and making the authorized change. So what's very significantly different in the TessPay environment is that that kind of social engineering fraud is not possible, because the carriers need to make those changes themselves. So right now, if you're a supplier, you authorize traffic from your customer by IP address. So you say that, okay, keep using AT&T as an example, AT&T is sending me traffic, I know that AT&T's IP address is x.x.x.x, and they're going to send this prefix, which is essentially a password, that authorizes them to send that traffic. So what happens is somebody could say, oh, I've got a new piece of equipment pretending to be AT&T. So then the supplier opens up access to that IP address, and then they pump it with thousands of calls. And then not until the next billing cycle do people realize, oh, shoot.
So for the little guy, I don't have to disclose all that information. I control my IP address, so I don't have to rely on receiving something to say, open this for me.
That's correct, because on the TessPay platform, everybody enters their own information. So you enter your own authorized IP access list, you enter your own banking coordinates. So there's nobody else making requests for you to do that. And the additional thing is that for sensitive information like this, it requires 2 administrators to approve it.
It sounds like much better security, not allowing those
we
things
think
to
so.
be cleared. On the other side of telecom fraud, what else happens besides the finance and social engineering?
Right, so we can't get into all kinds of telecom fraud in this session. That's beyond the scope of today's session, but I would at least like to talk about premium rate number fraud, because it's probably the most costly and most prevalent.
What are premium rate numbers?
So premium rate numbers, you may not know it by that name, but you're probably familiar with the concept. Essentially what this is a private company would obtain a number range from a tier 1 operator, ostensibly to provide, in my view, semi-legitimate services like horoscope or adult content. So what they're able to do once they obtain these numbers is they can create any rate plan they want. They could charge $5 a minute for the first minute, $3 a minute for every minute thereafter. So what the fraudsters then do is they cause as many calls to be directed to their numbers as possible, because they get to collect the revenue for any call that's sent to those numbers. So they use various techniques to do that. So one technique is to use an IVR dialer. So what they do is they'll populate this dialer with a database of millions of numbers. They'll make millions of phone calls, and they'll let that number ring like maybe once or twice, and then they'll hang up. So they'll have no charge for making the calls.
So what's
But they
wrong
know,
with
well, because they know that there's some small percentage of the people who receive those calls will dial back on that missed call. They'll be curious, who called me? And so what'll happen is that whoever makes that call back, they're gonna get that charge. So they're gonna get, I don't know, $5 charge, $8 charge on their next phone bill. Now, probably a lot of people wouldn't even notice that charge. And even if you did, are you going to bother spending your time to call your carrier to dispute the $8 charge? You're going to say, you know what, it isn't worth my time. Unless you're my father-in-law, then no amount is too small.
Also, you mentioned earlier about prepaid SIMs. How's fraud with those?
So this is just another technique they use to cause the calls to be directed to these numbers. So what they do is they search the globe for prepaid SIM cards where the operator that has issued those cards has not yet had an opportunity to block those calls. So they don't know about those new codes, so they haven't got it in their blocked call list. So as soon as they find cards that have kind of a routing hole, then they'll direct thousands of calls to those numbers, and then of course collect the revenue, but the carrier that issued the cards will actually have to pay the bill. Obviously they won't have any offsetting revenue.
Very sneaky.
So now just before we go on, one more point is that in its current implementation, TessPay cannot stop all of that kind of telecom fraud. It completely eliminates the financial fraud. The telecom fraud, we can mitigate it, but with the cooperation of the tier 1 carriers, I believe we could actually stop all of it. And that's currently 11 billion a year.
That's worth attacking.
I think it's worth a conversation.
Absolutely. So with these carriers setting up these routes, they have to get paid, there have to be financing. We've addressed fraud, but liquidity. What's going on with liquidity in the market?
Well, the liquidity problem arises due to the nature of the industry. Because you're dealing with long distance minutes, quite frequently your counterpart is also international. So it's difficult enough to assess credit with a local party, never mind if you're dealing with an international counterpart. So it makes assessing and making quality credit making decisions definitely more problematic.
And when you make these decisions, are the margins high for these types of calls?
No, so wholesale telecom is a very high volume but low margin business. So when you grant credit from carrier to carrier, it's actually tantamount to granting it to giving the other party a bank loan. And the funny thing about this is that if you went to your bank to ask for the same credit that you're asking from some carrier, probably in most cases, because you're dealing with these smaller operators, the answer would just be a flat no from your bank. So it's kind of funny that you're able to obtain credit from these other parties.
Because you started off as a CPA in this.
Yeah, so with a financial background, it always amazed me in this industry how much credit was so freely granted, and in many cases on an unwarranted basis.
So with credit now, and you have payments, obviously there's late payments in this mix. How does that affect the systems?
Yes, sadly, late payments are also endemic. And the problem with late payments, I mean, obviously it's not the same as just not getting paid at all, but it creates cash flow problems. So, because you're into a constant cycle. So when I ran my carrier business, we would every single day create a spreadsheet making a list of the customers and the customers that were due today, customers that were due today but were likely to pay tomorrow or likely to pay 2 days from now or 3 days from now, whatever. And then we'd make a similar kind of list with the suppliers, just kind of setting priorities, meaning, you know, the highest priority supplier would be someone, if I don't pay them today, they're going to cut me off. Or then the next column might be the guy who's going to scream really loudly at me, and then kind of fading away from there.
So what are your loss recovery options?
The loss recovery options are not great. I mean, much like the credit granting decisions, it's, again, difficult enough if you have a loss with a local partner, never mind having a loss with an international party. I mean, probably in many cases you don't speak the language, you certainly don't know the legal system. So to try and fight that machine in another country for several years, I mean, the reality is you just have to write it off.
But can't these contracts be insured?
Certainly, I mean, and many of them are, and insurance does help, for sure, but it does not eliminate all the problems. And the problem with insurance is that you don't necessarily get the recovery, because you've got to make a claim with the insurance company. They're not necessarily always going to agree with your claim. If they do pay out your claim, they're probably not paying it out 100%. Depends on the policy, it might be 80%, 90%. And the other problem is that when you do get paid the claim, it can take several months for it to arrive. All the while, you're in a cash flow problem, which, coming back to this concept of having very low margins, when someone doesn't pay you a big chunk of money, that's taking out a lot of your ability to keep everything flowing in your small business.
With all these issues, how do carriers finance today?
So other than self-financing, they can have access to accounts receivable factoring. So there are some specialized lenders that do lend into this space today. The problem with that is that this whole process is very time consuming and expensive.
So give me an example of how that works.
Right, so typically what would happen is that a supplier that has a contract with a financeable party, so a large company or a tier 1 operator, would make an application to a lender. That lender would want them to go through a due diligence process. So that might be a review of their formation documents, their financial statements, obtaining undertakings from their directors. The other thing is that the lender will also want the customer who's being financed. So in other words, that supplier who's applying for the credit and their customer whose invoices are being purchased, they want them to sign a 3-way agreement for what's called a notice of assignment and a direction to pay. So a notice of assignment is an acknowledgement by the customer that their invoices are being purchased by a lender. And the direction to pay is a further acknowledgement that when the invoices are due, instead of paying the bank account of their supplier, they're going to pay the bank account directly to the lender. So the further problem with all this is that a lot of the tier 1 operators won't sign these agreements. Like I kind of know anecdotally that maybe half of them will and half of them won't. Now, for the ones that will sign the agreements, they still need to go through yet another legal review process because there's these additional legal documents, and they typically want them to be in conjunction with a business case analysis. Now, the absurdity of the business case analysis is in this industry, it's actually much like the stock market. The prices are changing fairly frequently. And so it would be, because a legal review can take some number of weeks, it'd be akin to making a purchase decision to buy a basket of stocks for a short-term hold based on prices that are 3 months ago.
Let's talk about how they contract with each other today.
Okay, so today they enter into essentially what I would call a paper-based legal contract. So that first contract is a master services agreement, containing all the general terms and conditions that would govern how they exchange traffic, and also would include, most importantly, the payment terms. After they sign this master services agreement, they have to go through an interconnection process, which is essentially a synchronization of the 2 carrier switches. And so they just send test calls back and forth to each other, ensure that the call detail records match. Once they do, now from a technical perspective and a legal perspective, they're ready to start conducting business with each other. In order to actually start doing business, now rates have to be issued. So this is the rate amendment process. So essentially what happens is the supplying carrier produces an Excel spreadsheet with a list of the country names, the codes, the prices, etc., and sends that price list off to the customer. Customer loads it up into its system, into its routing tables, and then the traffic can commence.
So it sounds very complicated. That's a good overview of the wholesale telecom. So let's talk about TessPay itself and the TessPay actual solution. We have fraud, we have disconnected, we have financing. Let's talk about the model as TessPay contracts and smart contracts.
Sure. So what's different in the TessPay model is instead of entering into these paper-based agreements, the carriers would instead enter into smart contracts with each other. And a smart contract is essentially a programmatic representation of a legal contract. So once that contract has been signed by both parties, it gets written to the blockchain and can't be changed by either party without mutual consent.
So we're going to show you some quick videos here, but we're a little light on time, so I'm just going to move forward. We'll have these at the end if you guys want to see the actual system. So are smart contracts legal contracts?
No. So as I mentioned before, they're a programmatic representation of that legal contract. So it's essentially a set of business rules that have been programmed and will execute when certain trigger events happen. So in the TessPay model, there are still legal agreements. So if there are any lawyers in the crowd, you're not out of a job yet. Anyways, but on our platform, we make entering into and tracking these agreements an awful lot easier. So there's 3 different agreements on our platform. So there's the TessPay platform agreement, which was entered into by either a carrier and a lender and TessPay, which essentially governs how they'll make use of the platform. You can only use it for telecom services or for lending services. It can't be used for some other purpose. And this is entered into only once during our KYC process. Excuse me.
So
the second thing is, is the smart contract.
So these are actually paper contracts embedded in the system that you're going through right now.
Yes, I mean obviously they're presented to you electronically, but they are just essentially
Right.
like
So
paper
true legal
contracts.
documents to match with the smart contract.
That is
blockchain.
correct. That is correct. So in the case of the smart contracts, this is entered into between the buying carrier and the selling carrier, and explains in legal terms how that smart contract will actually be executed. Now the nice thing is that the content of that document doesn't change from smart contract to smart contract, so the legal review really only has to happen once.
So you do it once, and then you can make agreements with multiple carriers.
Correct. And then, you have to agree, you have to agree to the terms and conditions every time you sign a smart contract, but you know that those legal terms and conditions haven't changed, so you don't have to reread them over and over and over again.
Got it.
And then the last thing is that if a supplier is financing or requires financing for a contract they've entered into, we have a lending agreement they have to enter, of course, between the lender and the carrier. But what's important to note here is that, as I mentioned before, the lenders wanted a three-way agreement. There's no three-way agreement here. It's only between the lender and the borrower. So you're not having to involve that customer acknowledgement, direction to pay, etc.
Streamlines the process.
Yeah.
So I understand TessPay model guarantees daily payments, which is unique in this industry. How do you do that?
The way we do that is that the first contract, so in my example here, smart contract number 1, we call that the origination contract because that's where calls originate onto the platform, and that contract must be prepaid. Okay, so if that contract's prepaid, then we know that we're in a position to make the payments downstream to all the other smart contracts and carriers that are
Do
prepaid.
all the contracts need to be paid, or just that first one?
Only the first origination contract needs to be prepaid because the derivative contracts, what we call standard contracts on our system, can only receive traffic if it came downstream from at some point in origination contract. So they are already in effect prepaid.
So are tier 1 carriers going to move from postpaid to prepaid?
Certainly not. I mean, if they're getting 60 days financing terms today, why in the world will they move to a prepaid environment? They're just not going to do that. But this is where the lender enters the picture. So a lender is happy to advance funds to an origination contract with a tier 1 carrier because they know that those parties are financially sound and they most assuredly will pay their invoices when they become due. So essentially what's happening here, if you remember my previous example, we had that financing happening in that uncoordinated way through the chain, that we're pushing all of the lending to the top end of the chain to the contracts with the carriers that have the balance sheets that can actually support the lending.
That makes it easier, so then downstream everything flows.
Yeah.
How do suppliers attend financing for TessPay? You mentioned earlier.
Yeah, so on our platform, that's actually really easy to do. So the supplying carrier, who is the borrower, once they have a signed contract with a financeable carrier, there is a request funding button associated with every smart contract. So they just simply have to click the request funding button, input the estimated financial, how much they think the spending would be each day. So let's say it's $10,000 a day, $5,000 a day, they input that value and then they click submit. The lender is going to receive that financing request in real time. And in most cases, will probably make a lending decision within the same day.
So these lenders are on the platform itself.
Yes, they're also on the platform. And then the final thing is that once the lender has made an offer of financing, of course, the supplier that's requested it, because they have to pay the interest, has to accept it. So they click an accept button. If they do, the smart contract is immediately financed, and then the traffic can commence. Now, this is in stark comparison to the existing process that can take 2-3 months to obtain financing.
Yeah, this
And
sounds like
a
lending
lot
on
of work.
demand.
Yeah.
Instant. That's wonderful. So let's talk more about, well, these are videos. I'm going to skip the video of the lender, how we do it in the system. Let's talk about the money on the TessPay platform and where it actually resides.
Sure. So all the money in the TessPay platform goes to a special depository account that we have with Northern Trust. And so this, you can think of this much like opening up a brokerage account. So if you open up a brokerage account to buy stocks, of course you would start with a zero balance in your account. If you wish to buy stocks, you have to fund that account either by wire transfer, check, some means. Then you can buy and sell stocks. If you wish to liquidate them, you can request a withdrawal from your brokerage account. It works exactly the same way in the TessPay environment. So you first sign up an account. Of course, you start with a wallet with a zero balance. If lenders wish to finance transactions, they need to make wire transfers into the system to finance those transactions. The carriers that deliver services, they accrue revenue into their wallets and their account. So, of course, any carrier or lender can request a withdrawal from the system of any positive balance. And we'll deliver that the next business day by, bank wire transfer, ACH if it's here in the United States, or PayPal.
So how's blockchain relevant to these wallets?
Well, what's significantly different than having a traditional brokerage account is that because this system is connected to the blockchain, that the participants on our system will be able to query the blockchain and confirm that the aggregate of the wallet balances on the system actually match the real bank balance in Northern Trust.
I see. So every day there's payments, so how do settlements work? How do they settle and decide where all this money flows?
Right. So settlements happen on the system daily. So that means, for example, the traffic that happened on day one would be settled in the early hours of day two. So I'll just give you an example. So let's say that a supplier estimated that they were going to use $10,000 a day. So on day one, a lender would have advanced, I'm assuming this is a finance transaction, so a lender would advance $10,000 to the smart contract. And then let's also assume in this example that the actual traffic that happened on day one was $9,000. So here's what happens with the payments. So in the early hours of day two, supplier A would issue an invoice, well actually the system does it on supplier A's behalf, to the, let's say the tier 1 carrier. Then the system would automatically transfer $9,000 out of the smart contract wallet into the wallet of the supplier, so supplier A in this example. And then simultaneously, any cost that supplier A has incurred on the system will be removed from his wallet. So in this example, there's $8,500 of cost, which is an invoice they would have received from supplier B. So that $8,500 comes out of his wallet, and then at the same time, the TessPay fees and any interest that a lender is also removed. So what's happening here? Sorry.
I'm trying to move you along. As we go through the platform components really quickly, what puts together the system?
I need to change that. Okay, so very quick, I'll start talking faster than I get. So the customer, so we have the customer portal, which is the user interface that allows the carriers and the lenders to create smart contracts, do their routing, request payments, lenders to approve transactions. We have the Telecom switch and billing system. These are two subsystems that are fully integrated with our portal. So the Telecom switch is a third-party system that we've integrated, a company called Catalea, and then the billing system is an American company here called Fastlink. Been in the industry for a long time. And then finally, we have the TessPay IBM blockchain.
So that's the Hyperledger blockchain. So why do we need a blockchain for this?
Well, we need a blockchain for supply chain for the same reason that we lock our doors, create passwords, deploy firewalls. It's because most citizens are fundamentally honest. However, there are those among us, not in this room, that are not. And they're the ones that cause all the rest of us to have to go through lengths to protect ourselves.
So how does blockchain help? How does blockchain help supply chain?
As I mentioned earlier, once you enter into that smart contract signed by both parties, it can't be changed without both parties' consent. And the problem with written agreements is that they're subject to human interpretation and trust. And with with smart contracts combined with a financial instrument that is attached to that smart contract, once the services have been rendered, and in this case, it's a closed loop system, so we know when the service has been rendered, then payment happens automatically. So you're just completely eliminating trust from the equation.
So what's the TessPay and IBM blockchain relationship?
Sure. So the TessPay IBM blockchain is a private and permissioned blockchain that was actually built by IBM and hosted on IBM's dedicated blockchain cloud.
And you went through garage sessions to create this?
Yes, we did that quite a while ago now. That was actually quite a good process.
So what's it meant by private blockchain?
So private meaning that only carriers and lenders that have passed our KYC process are actually permitted to be on the platform.
So the privacy is important, obviously, in telecom?
Yeah, it's very important. So the carriers fiercely protect who their suppliers are and their associated rates. I mean, that non-circumvention is one of the biggest concerns in the industry. So while any participant can query elements of the blockchain, if you're not a party to a contract, you cannot see the details of that contract.
So why IBM Hyperledger Fabric?
When we were originally building our prototype system, we took a look at a number of different blockchain options, and in the end, our technology team decided that IBM would be our best partner. I mean, we needed a robust, scalable, trusted, private, and permissioned blockchain, and I have this little quote. Something we felt that only IBM could reliably provide for the high volume of financial settlements TessPay be processing on a daily basis.
Because this industry is huge, and the system could potentially take millions of transactions, and so we need a scalable environment.
Absolutely. So certainly, looking at a public option, that was just not an option. But we also wanted to partner with someone who really understood the business and understood the scale of business that we were dealing with here, because we're talking about trillions of phone calls eventually. So anyway, so in the end, we're very pleased to call IBM our blockchain partner.
Absolutely. Other features and benefits to services of TessPay.
Okay, if we're running short on time, we'll do this. I won't go through all of these things.
Yeah.
So firstly, we have a much lower operating cost. So right now, if you're a voice over IP carrier, you of course have a voice over IP switch, which means you incur hardware costs, software licensing costs. You have to have that equipment stored in the data center. You incur bandwidth costs. You need technical people to support that, and you need administrative people to issue rates, do invoices, record payments, etc. So all of this is quite costly, especially to a smaller operator who doesn't necessarily have the scale. So what happens on the TessPay environment is that all of those services are already included.
It's like having it in the cloud.
Right. So if you sign up to our system, which there's no cost to sign up for, it's a pay-per-use system.
No upfront costs?
No upfront costs. So they get a virtual switch on our previous diagram I explained. We had a switch by Catalea. They get a virtual switch with an unlimited number of ports. Of course, our system is supported 24/7 from a technical perspective, and due to our automated settlement process, there's no need for an administrative person to be issuing rates and reconciling payments. And then
So it sounds pretty turnkey.
Right.
So this is like easy as 1, 2, 3.
Yeah, but one more thing I want to make in the last slide is that the fees that we charge, getting the warning, the fees that we charge will be far outweighed by the cost savings that the carriers will incur.
Absolutely. So easy as 1, 2, 3.
Yeah, we think that the benefit from using the system for the carriers, if they wish to participate, is as simple as interconnecting, creating smart contracts, and then collecting daily payments.
I think we can wrap and ask for questions.
Sure.
The rest of the videos. Yep. Last one. What's next for TessPay?
So we certainly are not naive enough to think that we can go and attack all the rest of the other industry segments right now. But we'd like to think that once we've established ourselves in wholesale VoIP, that we could move next into the mobile roaming sector, which is actually a $500 billion market. It's about 10 times the size. And it also has the problems of fraud and other issues as well. And then who knows, down the road, perhaps into other industries, the same kind of concept could be used.
Using the
oil and
technology.
gas, energy, etc.
Wonderful. Well, thank you for coming out on Valentine's Day, and we can open it up to any questions you might have.
Yes.
I have one question. Curious about the architecture of the network, and if you require your supplier, your customers to run nodes, how did you deploy that blockchain?
Yeah, so the blockchain element right now, we're running a node and IBM's running a node. And so the idea is that if there are any other major stakeholders that wish to run a node, then we'll consider doing that. So it's completely different than a public blockchain where you've got all these different nodes. We don't need that. I mean, really, we need enough and by credible parties to know that the data isn't being manipulated.
And the transparency, all the parties of a contract, so the buyer, the seller, financer, they have exposure to those ledger actions and transactions, so they can all confirm, and then the third party.
Okay, so you use IBM as a trust anchor in your organization.
You got it.
We're looking into that, and we're also looking into other, like our accounting partners, having a trusted node as well. Good question.
How did you find the technical integration of the blockchain environment with IBM into your current existing platforms and both modern software stacks?
Yeah, absolutely. We went through the garage sessions, we did the MVP part. It's a modern stack with microservices, all the current technologies, so everything is, each system has its own API sets, so we use the Hyperledger API couch pieces, and so we have a fluid, scalable connectivity rack. So the Hyperledger stack really works for us.
So for your payments, payment itself is off-chain on the Northern Trust side, as I understand. Do you have direct integration with them, or do you use like a Swift-based messaging network to trigger payments?
Yeah, it's a Swift-based system. So, I mean, I should clarify, there's probably most of you know, blockchain is not synonymous with cryptocurrency, and so in no way are we using cryptocurrency. So everything is, in this industry, is either done in USD or euros for the most part.
Right. But we are looking, and when we evaluated banks, we did evaluate banks that had the potential to do more electronic transfers, but right now it is Swift exchanges, exactly.
Or ACH.
ACH, right.
Do you find that the sort of the scalable pricing models for like services, these APIs, do those stay pretty constant so that you can plan for your business like going forward? Like there's no like spike at some sort of traffic rate or anything like that. You feel comfortable with all those pricing models for the deep integration?
Yeah, so the way the architecture is built, we're all volume based. So when customers sign up and they're only paying for calls that they actually use, our services scale the same way. And so we're not paying extra capacity right now. And as they scale, both with IBM's help and or their architectures, our billing system, and our virtual switch, they scale as well. So we're not overpaying now, and as volume increases, it covers those costs.
How many of the tier 1 players do you currently have in the system?
So we're actually just in the process of bringing on our first test customers now. So we're not bringing on a tier 1 carrier as one of our first test cases, although we do have one of them lined up to do that as soon as we're finished this first segment. So maybe about a month from now, we'll bring on, there's a large tier 1 operator in Europe that's agreed to do a beta with us.
And what kind of challenges do you foresee persuading the CFOs to change the way of money flow?
I think it's not so much a change of money flow. I think it's mostly a legal review that's going to be the sticking point with the tier 1 operators.
Also, the algorithm signing the payments with the third party.
Yeah, and at the end of the day, the way we have the payments work, they're not really directing the payment to a third party because they have an account in our system as well, not a virtual switch. They still maintain their same infrastructure. So from sending the traffic perspective, nothing changes. I mean, right now they send to some IP address, so now they're sending a different IP address, nothing changes. So they're used to now making a payment to a supplier or financer. So in this case, they're going to send the payment into our depository account, but because they have an account in the system, they're effectively funding their own account. And then when they make a payment of an invoice, that shows up on the platform, and they just click the invoice they want to pay, and that happens within the wallet system within the platform. So I do believe that they will initially have some reticence with the new legal model. I mean, actually, I had one little quote that I wanted to put at the end, which is kind of appropriate for the tier 1 carriers. I was just saying, it's okay normally to be confounded by new technology, but just like it was when the internet was evolving, soon too will blockchain solutions and advantages become obvious, and we'll wonder how we ever did without them, and why it took so long for these ideas to be invented. So I think, like many things, especially with large organizations that tend to be more bureaucratic, they're going to be a little slow to change, but then they're going to fall like domino when they see some of their other counterparts doing the same thing. So if you're a large tier 1 operator and you see another tier 1 operator do that, you're like, okay, you've already paved the way for me, you've done all the due diligence, I know that there probably aren't a lot of gotchas here, so it's okay too. So the first one will be harder, and then it'll start to snowball.
And we've seen this with the carriers on our platform now, the smaller carriers on our platform now that have come with a partner with a financer. They've gone through the legal review process has taken longer than the technical review. The technical, it's an IP address, it's a switch, we got it, let's go, hold on, legal team. So the platform agreements that Jeff talked about earlier, we submitted to them, they went through them, we brought it back on the system, they approved them, and now the technical teams are running. So we expect the same with the tier 1s, the same kind of more on the legal side, not on the technical side. Yes?
I'm not sure you regard this, but does TessPay make money by charging carriers based on volume?
Yes, that's exactly right. So it's a pay-per-use service. So we charge a small percentage based on the total gross invoice value that passes through the system. So that's what I'm saying. If you sign up for the service, it doesn't cost you anything. You don't transact any volume, it costs nothing. But if you pass traffic through the system, you're going to pay. So it's actually much like paying an insurance fee.
So
Yeah.
is it the carrier who's charged or is the...
It's actually the supplier. So if you've got a contract, let's say AT&T is not going to pay that fee. It is the supplier to AT&T that's paying that fee.
So think about, Bluemix, AWS, and Google. This is Telecom to the cloud. You sign up, you have your whole infrastructure in the cloud, you put your information in, you get an agreement with another carrier, you get financing, you run traffic, and you only start paying for things when the traffic goes through. Well, thank you. We appreciate you guys.
Yes,
coming
thank you
out.
very much for coming in.
We are a very unique use case, airlines. So their competition is, you're gonna get a package today, so instead of